Thank you for the introduction, and thank you so much, CAE, for this opportunity. I feel fortunate to be able to share my research with all of you. Um, so a little bit about myself. My name is Phani Vadrevu. I'm an assistant professor at University of New Orleans. Started like 2 years ago. This was a work that I did as I was transitioning from my postdoc position at University of Georgia to University of New Orleans. So it's joint work with my advisor, Roberto Padici. And okay, so a little bit more about myself. I am, as I said, a faculty member at University of New Orleans. I conduct research in cybersecurity, more specifically web security. So my focus is on using machine learning methods to find, new defenses, new attacks in the domain of web security. Recently, my research interests kind of moved towards social engineering, and that's one aspect that'll be covered basically in this talk. And I'm a member of UNO Cyber Center, so a group of faculty members, researchers, undergrad and grad students at University of New Orleans. All of us conduct research in various aspects of cybersecurity. We do network security, forensics, system security, web security. So if any of you are interested in working with us, please do look us up, and feel free to email me. I'll be happy to answer any questions. And of course, New Orleans is a great place to study and great place to research also. So I'll be happy to answer any questions you might have on that. All right. So without further ado, I want to start with our talk. So um, my talk is titled "What You See Is Not What You Get." So it's about discovering and tracking ad-driven, advertisement-driven social engineering attack campaigns. So one thing I want to say is I want to talk about like the motivation behind this, right? So I guess maybe for the past 4 or 5 years, as long as I was a student, I saw one common trend, which probably many of you might have seen and probably still see, right? So let me give you an example of that. So let's see. All right. So the trend is this. You go into, say, google.com, and you say you want to look for a movie. So okay, many times maybe you want to look for a free movie, so you type in watch English movies free online streaming. By the way, these are all real screenshots. I didn't make this up. These are all real screenshots. And next, uh, uh, you type it in and you get a search results, right? So all right, the first one looks good. It promises to show you free movies. All right, so let's click on that. You select that and click on it. Moving on, that opens up to be like a new good website, really good, neat looking one. There's a search bar there, and okay. So instead of, you can type something in the search bar, or maybe you mistakenly click somewhere, right? Anywhere in this web page you click. If you click, and I did click, right? And what really happened was that a pop-up ad opened, and that pop-up ad from a domain name, you can see the domain name. It's kind of wants to make you think it's apple.com, but it's not, right? So it's actually com-optimize-mac.live. It's right, it's not apple.com, but they're trying to socially engineer you into thinking that it's apple.com. All right. More importantly, it says that they've detected a Trojan virus on my Mac, right? And click OK to begin the repair process. All right, so I was like, okay, let me click on OK, and let me click on maybe scan now. So they scanned and they said, I don't know, my system is infected. And they said, hey, I think download an executable and run it if you want to clean up your machine. Okay, I downloaded the executable and immediately uploaded it to VirusTrotal. Of course, I was smart enough not to execute it, but I uploaded it to VirusTotal. And immediately, what I saw was that this executable that I downloaded, uh, VirusTotal, of course, has a host of antiviruses. I'm sure many of you might have heard of it, given the audience, right? So I've uploaded it to VirusTotal, and it said that 17 antiviruses on VirusTotal said this is malicious, right? So clearly this is of course the executable itself is malicious, but it's being kind of advertised uh, as an antivirus, right? So this falls under the spectrum of fake AV. So we are familiar with this, but what really interested us in this, what motivated us was, why did such a fake AV selling website show up as, like, first in Google's results, right? This is probably a benign query. I'm not looking for malicious, right? So this is something probably many of us do as, like, I don't know, students who are looking to watch movies, right? And another concerning thing for me when I did this, so was, first of all of this project was done in, let's see, in Georgia, right? So I was a student at University of Georgia. I came over to University of New Orleans. So all of this research was done in Georgia and Louisiana. But these screenshots I've taken them in Amsterdam. So where I was presenting this paper as a conference. So you see this phenomenon is not location dependent, and it's not time wise dependent too. So these screenshots I've taken 2 years after my project. I was so confident that it'll happen. I took it one day before the conference, and this happened. So what makes these malicious advertising campaigns so persistent and uh, show prominently on Google search results, and I don't know, so present in every location. So what makes them happen like this? So these are like kind of like our primary motivation, like why is this happening, right? And one more concerning thing is, when I took these screenshots, right, I had a really good ad blocker extension, right? It was installed, and this was a brand new version of Chrome. And at that time, Google came out and said that, hey, we're going to block intrusive and misleading ads. So it is supposed to block intrusive and misleading ads, the browser. Apart from that, it has this very popular ad block extension called ABP, Ad Block Plus. You might have heard of it. None of them were able to stop this attack. It was still happening, right? So this is again the motivation for us. What are these, like, which ad networks are responsible for that, and what is causing this? All right. And okay, one thing I want to say as I keep going is that I don't want this to be a one-way thing. We have, I think, a sizable audience. So if you have questions, many other people might have the same questions. So please don't hesitate to maybe use the Q&A channel that we have. Just ask me the questions, and I'll happy to answer them as and when, right? So uh, please make use of it if you have any questions. All right. So let me move on. Now, this wasn't the only thing we saw, right? Like I as a student, when I was playing around, it wasn't just this campaign. I saw a few other campaigns. Let me go over them. Another one was what I saw often in these websites were what are termed as technical support scams. All right. So you again click on it. The pop-up shows different content. These technical support scams, the content they show is, they say, hey, your system is again infected, but this time instead of asking you to download an executable, they'll ask you to call a phone number, right? It's a toll-free number. So what's the harm in calling them? Well, the harm happens if you actually call them. They'll try to connect to your systems and I don't know, sell you a phony product. At best, they'll sell you a phony product and rob you of $100 or $200. At worst, they might install malware and try to steal credentials and all that, right? So these are referred to as technical support scams. Because they sell themselves, they brand themselves as offering technical support. All right. So these were studied in previous research. While these were studied, what was an open question for us is, how are these being distributed via advertisements, and how is like in so prominent fashion? So always that was the question. Our question wasn't to study these attacks particularly, right? But how advertisements were playing a part in this. Moving on, what else did we see? um, Lottery or gift card scams. So they kind of again, a pop-up ad opens. You might have seen these on your mobile phones, and it say, "Hey, you won a lottery," right? So they kind of, you can notice how they are trying to imitate the design features of Amazon or Facebook, right? So these like button, this is all fake. So this is not a real comment, and it's just faking and telling you that you've won a lottery or a gift card. Again, this was studied in previous research and said that these lead to eventually malware, right? So we didn't go to that part yet, but we were interested in how these are popping up in the first place. Okay. Another kind of ads we saw was fake software updates. This is similar to the previous one, fake AV kind of a thing, right? So that I showed you in the beginning. So they say, hey, your Java needs update, hey, your Flash player needs update, and you need to download this. If you do download it, that's when there'll be problems. So these are all various categories that we were interested in. All right. So moving on. One thing I want to say is the note here. All of these screenshots that you see here is like, while the first screenshot, which is this one, is something that I took manually, all of these screenshots were taken by our system in an automated fashion. So the system that we built automatically discovers these kind of ad campaigns and takes screenshots of them. All right. So my most of my remaining talk will be focused on how we designed the system. Um, Give me 1 second. I'm trying to see. I think there's a question in the Q&A section. Unfortunately, I can't get to it.
Yep. So
Oh yeah.
the
First,
question is, are you able to see it?
yeah. I had to minimize, but I'm able to see it. Okay. How to recognize fake software update scams? Yeah, that is the topic of my presentation. So we'll get to how we designed a system that will recognize these kind of scams in an automated fashion, right? And the software update scams shown are very convincing. Oh yeah. So the design is pretty convincing, right? So I think these are only some screenshots we have, but we have a bunch of them. I have like probably 100 such convincing screenshots that our system mined for us. But yeah, they are very convincing and they do a good job, which is why they are in existence so much, right? Which is why they're so prominent, because they are convincing enough to fool people. Like I mean, from a user standpoint, whenever a whenever something pops up on a website, I think the first thing you have to check is the domain name. And generally, I don't think Flash or anything shows it up as a pop-up screen. So all these, from a user point of view, the best thing is check the domain name of the website, right? So before you download an executable, you have to ensure that the domain name, which is somewhat highlighted prominently. So let me go back to here, right? So here, uh, prominently, Apple is trying to tell you this is not apple.com. Like, well, Google, because this is Google Chrome, it's telling you this is apple.com hyphen optimize hyphen mac.live, right? So this is not apple.com. And to re-emphasize this, they're putting this in black, right? The domain name in black. Unfortunately, though, it has apple.com as the first part of the domain name, so which could fool some people, right? This is really an open problem. Um, the fact that this is not secure is only because they don't have a certificate. If they had certificate, then it would have said secure. And and the only thing that convinces the user is the fact that this is optimize-mac.live. So this is an open problem because this is still good enough to convince a lot of people who don't have the technical knowledge to think this is apple.com. And this has to be something that has to be done at a domain registrar level or something like that. But yeah, that is an open problem, and which is why eventually, so again, my motivation behind this talk is to show you these problems, and you as students or researchers in this field, um, that we as a community as such have more things to do in this domain, because there are people there who might fall easily for the attacks, and we need to come up with better systems to stop these kind of attacks that are happening. So the solution we present is not like one solution that will work for everything. As you might see, it's a really simple solution, but more important point of my talk here is to show that there are a bunch of problems here that we as a community need to focus on. All right, let me move on. And yeah, but good questions, thank you, please keep them coming. uh, All right, so these were all screenshots not taken by me manually, but like I said, taken by my system. So how did we go about this? That will be the focus of my talk. Um, More importantly, our focus was uh, to define our focus. We had to come up with like we have to have clear terminology. From a research point of view, things become clearer only when you have like a clear terminology. So so we had to define this terminology. What we did was we defined a term called SE attack campaign, or social engineering attack campaign. So what is an attack campaign is whenever a set of ads or advertisements happen on different publisher websites, right? So what is a publisher website? Remember the first screenshot I showed you where there was a website that is saying, hey, I will offer you free movies. That's a publisher website, because that's a website that is publishing the content. Okay. So if you see a set of advertisements from different publisher websites uh, that lead to identical SE attack content, right? Identical SE attack content. Why identical SE attack content is, my observation manually before I started this project was that I would go to tons of these websites offering free movies or free NFL football sports games or whatever, right? So I would go to these websites, and on each different website, the same kind of advertisement used to show up, right? So if I click on it, a pop-up ad opens, and the same very similar look used to pop up, right? So that is what led us to this definition of campaign, because it's a campaign, right? It's not just one website and one thing that's showing up. On multiple websites, the same things are showing up. So this collection of screenshots that visually look really similar, but they pop up on different websites, we call them a campaign. Okay. More importantly, the pop-up that opens up like on a new tab, it is shown on not it. So that's what we call as a landing domain. Okay. So again, going back to terminology, sorry, I'm going back and forth, but just to make sure that things are clear, right? So this is the publisher website, movies123.org. This is a publisher website. There could be another one, nflfreegames.com, right? So that's another publisher website. So on multiple publisher websites, the same attacks are showing up. Also on multiple landing domains. So this is the landing domain. So when I make a click on this, a new ad opens up, right? That advertisement opens up in a different domain. Okay. And this domain keeps changing every time. Why? Because this will be very quickly, probably in a matter of a few hours, uh, Google Safe Browsing blocks it. What is Google Safe Browsing? It's a block list of domain names. Again, some of you might have heard of this. Every web browser, every popular web browser, you think of it like uh, Google Chrome, Safari, Firefox, all of these browsers, they come inbuilt with this block list called Google Safe Browsing. So Google plays a very important role in securing our web, whereby any domain like this, which shows up, which they know to be malicious, they'll add it to the list. But for them to add it to the list, it takes a few hours, right? Within those hours, that's the window during which they will attack. The moment this domain ends up in Google Safe Browsing's list, what do the attackers do? They quickly change the domain name. All right. So that's the landing domain. And for this reason, so I look up one website now, and I look up the same website a few hours later. The same attack shows up, but it shows up on a different domain name, a different landing page. Okay, so that's what we mean by landing page. So going back to this terminology, what we noticed is that the same set of ads leading to like similar attack content are show up on different publisher websites and on different landing pages. Okay, so that is what we define as a campaign. So applying this terminology, this is one campaign. This is another campaign. You see two campaigns here. Okay, and you see three more campaigns here. So five campaigns. So all of these are what we refer to as attack campaigns. Okay, with that as the definition, we were able to call what we refer to as seek my attacks. So seek my attacks are attacks, social engineering attacks that make use of these campaigns. Okay, and they work via advertisements, malicious advertisements. All right. So with these definitions, we were in a position to pop up our research questions. And our research questions are, what type of sigma attacks are in existence? What type of these attacks are in existence, right? So can we discover and track them in a generic and systematic fashion, right? So it's one thing for me as a student to click on some websites, and it's another thing to have a system that would automatically do this and tell me, hey, these are the attacks in existence right now. Okay, so that's what we wanted to go to. So can we discover and track and even track them, right? Across time, can we track them in a generic and systematic fashion? Next, obviously, these are being driven by ads and ad networks. So what kind of ad network supports them? Like, I don't imagine, of course, Google is an advertising company, Facebook is an advertising company, but I don't imagine them doing this because these ads don't show up on New York Times. Actually, they do show up on New York Times sometimes, but in general, they don't show up on popular websites. They show up on sort of like low tier websites. So like those that give out fruit movies. So what kind of uh, advertising network infrastructure supports them, right? Can we name the advertising networks, for example? So that was another goal. Another goal was what kind of publisher websites leads to these sigma attacks, right? So previous work, for example, the work that I have in the slide right now, so they showed that free live sports streaming websites show these kind of ads, but that's too specific, and we were like, no, that can't be the only category. There might be many categories out there. So without fixating on one category, can we come up with a system that in a generic fashion discovers all these categories out there? So that was another question. So we didn't want to fixate on one kind of publisher website. All right. So to answer all these questions, we designed our system, and this is the overall architecture of our system. Okay. So the rest of the talk, what I want to do is go over each of these steps, the components of our system one by one. And I think I'll come back to this slide at the end of my talk once we ran through all of this. All right. So my biggest question was, we didn't want to fixate on any one publisher website, right? Like not just streaming movies or not one category. I wanted to keep it generic. So if we want to keep it generic, where do we start? So that was the biggest question. And what we decided was, well, these are ad driven, so let's start with ad networks. And I've basically looked up, I think, looked up on some certain forums for ad networks and publishers. And what I realized goofing around these forums is that uh, the, uh, if a publisher has shady content, let's say, suppose you are a website, you host illegally movies. Okay. So if you approach Google to show their ads on your website, will they accept you? No, they won't, because you are definitely in violation of their terms of service agreement, right? So they strictly have a terms of service rule that says do not host illegal content. If you host illegal content, we are not going to put our ads there, right? We don't want to make money off your illegal content. So they clearly have those terms of service, which means that you, as a publisher, if you want to make money on your website that is hosting movies illegally, then you will have to approach unscrupulous low tier networks, right? So what are these unscrupulous low tier networks? There's a bit of manual work here. What we did was we looked around online, for example, posts like this that say, hey, these are the alternatives if your website is not good enough for Google, right? So we looked at those alternatives. And a lot of these alternative ad networks, they were also called as pop under ad networks. Why they call pop under ad networks is that they all these ad networks support pop under ads. So what are pop under ads? No, well, this is a bit of a UI concept. I mean, human computer interface HCI concept. And the thing is, psychologically, we as users, if we click on something and a pop-up ad shows up, we are so trained to be annoyed by these ads, we immediately click on cancel, right? So that is why these ad networks realize that instead of showing pop up, let's show pop under ads. Okay, so that way at least this psychological concept of clicking on cancel doesn't come into play. As and when the user actually goes to the pop under, they will pay more attention to the ad. So that's why these are pop unders. And by this technique itself, it kind of looks shady, right? So, and that's the reason why they support. So these are all shady low tier ad networks that support malicious content to be advertised. So we got names of these ad networks. Once we got names of these ad networks, what was the next thing we did? We basically went to these ads. So these are some names of these ad networks. We can put their names here simply because we have evidence, strong evidence that these support malicious content, right? So these ad networks, what we did was we went over there whenever needed, and we said, hey, we are a publisher, we have a website, we want to show ads, and they'll freely share with us their JavaScript code. So we put that so we looked at the JavaScript code and found out certain fingerprintable code segments. And what we did was we used source code search engines. Like, for example, there's a website called public www. So it's basically a source code search engine for the internet. So you can look for JavaScript's code segments, and they will tell you all the websites out there that have that JavaScript code. So we basically, using these source code search engines, we were able to figure out in a generic fashion all the websites that are hosting these ad networks. All right. So that's our first step. This way, we got a list of all the publisher websites that are hosting these low tier ad networks. All right, so once we were there, next what we did was we built an elaborate crawler form, right? So using Docker-based architecture, we made these crawlers work in a headless mode. No human needs to see them, so it'll keep it efficient. And on each node that we had server, we had multiple crawlers. One crawler pretends to be a mobile phone, one crawler pretends to be Mac OS, one crawler pretends to be Windows. So we had these multiple crawlers pretending to be something else and something else. And from a previous project of our own, we had an enhanced version of a browser, which would forensically kind of like record all JavaScript API calls that are made, right? So we had that, and we kind of like enhanced it even further for this project. And essentially, it will kind of like capture all JavaScript driven redirections during the attacks. These redirections are very important because once you click, physically you might think, hey, we're going from publisher to the landing domain page, but internally there are a bunch of URLs that we go through, as I'll show you in a bit. And it's important for us to capture all these redirections. That's why we needed this enhanced version of our browser, forensics browser. So we use that browser in all of these crawlers. And of course, we mimic, like I said, different browser OS combinations, because as you saw in the screenshots, right, the advertisements that show up on desktop are very different from the attacks that show up on mobile phones. And we wanted to capture all kinds of attacks. That's why we make different browser and OS combinations. And finally, again, if please feel free, go ahead and read the paper after this, but we used Chrome DevTools API. And the reason for this is that we had to use this DevTools API. We used a Chrome project called Puppeteer for this crawler. And using this API, we had to we tried first of all using Selenium for this, but Selenium didn't work out because some of these ad networks can recognize the fact that you're using Selenium and kind of like show you some not the malicious ads. They'll show you some placeholder ads. So we had to kind of like take additional measures to ensure that we kind of like remain undetected. And so this was one part of it. Um, Further, we had to instrument the browser code. We used Chromium for this project, and we had to make changes to the C code in Chromium. And the reason is that we had to suppress certain JavaScript dialogues that show up when you're interacting with these websites, because they will kind of like obstruct your flow. So we had to, and further we had to hide signs of automation. So even for this, we had to do some browser instrumentation. Again, the technical details are available in the paper. And furthermore, we recognize that um, these ads do not show up when you give away the fact that you're coming from a university IP address. So for certain ad networks, we specifically had to use residential IP addresses. For example, I use certain laptops in my home for some of these experiments. All right. So these were all certain challenges we had to face with the building the crawler form. But in the end, we did build a crawler form. So what does the crawler form do? It visits these websites, interacts with them just a little bit. Like for example, in the home page, it just makes some random clicks, and all the pop-up ads that pop up, it takes screenshots of them. Besides that, it takes the screenshot of it captures the JavaScript. Also, it captures all the redirections that happen from the home page to the landing page. And these redirections we noticed were very complicated. So if you used, I don't know, maybe a PCAP capture, it will not be good enough. So we have to have browser level capturing of redirections. This is very important because otherwise we cannot capture the full extent of redirections. For example, we've seen that websites use window.location, history.push state, add event listeners, or set timeout JavaScript calls, all of these to make these redirections. So that is why we had to do capture at a browser level all these redirections. Further, yeah, and why is this necessary, right? This is necessary because not only do we want to see at the attacks, we want to attribute them to the right ad network, right? In order to attribute them to the right ad network, these redirections which will or what will involve the ad network URLs. So we needed to capture them. All right, moving on. The biggest part is discovering attack campaigns. So when you open these ads, well, while a lot of them are shady, some of them are outright attacks, and some of them are like maybe mail enhancement products or some things like that, which are in the gray zone, but we don't know for sure if they are attack campaigns or not. But more importantly, we want to concentrate on the security aspect of this, right? Not on the spam aspect of it, but rather the security aspect of it, which is identify attacks like the fake flash, technical support scams, those. So to them, identify them, our main idea is this. Our main idea is essentially clustering. Okay. And the reason is that these pop-up ads that open for the attack campaigns, the same attack content shows up on different domain names, right? But if it's a benign advertisement, if it is not an advertisement that they're afraid will be taken down by Google Safe Browsing, then the same ad shows up on only one domain name. You see what I'm saying? So if the same advertisement shows up on different domain names, then visually exactly the same content, but if it shows up on different pop-up domain names, then that means something is wrong, right? That means it's probably malicious. So this simple logic is what we used, right? So we basically did perceptual clustering of screenshots that show up, and then threw away things that are from the same domain, retained only those screenshots that were from different domains. And whenever we noticed a large cluster, we basically guessed that this is malicious. Of course, we do manual inspection as well, but this is our system, right? So this is the way using clustering, we are able to identify malicious ad campaigns. All right. Then how about tracking, right? So once we identify a campaign as malicious, you can kind of, like I said, get the entire redirection chain. This is an example of one real redirection chain. So as you can see, it's a La Liga, or the Spanish league website. So which basically shows soccer games free streaming, right? So that's the publisher website. And this is a real redirection chain, and it goes all the way at the bottom to a technical support scam, right? So that's from that publisher website to here. And what is the redirection chain going through? It's going through another domain name, which is an ad network. Okay, so this ad network domain name is what we'll get through the redirection chain, and from there it goes to an advertiser. And here, one interesting thing we noticed here is that um, we didn't want to make so many clicks on publisher website, because it starts to affect ad revenue, and so it presents an ethical problem. So however, we know that this advertising networks, like this domain name, the attack domain name, keeps changing its domain name, right? So what we discovered is that you don't actually have to make multiple clicks on the publisher website to get here. What you can do is, once you get the chain, you can take an intermediate URL and kind of query it multiple times at different time levels. And each time you query it, a different attack URL begins to show up. Okay, so this concept is what we coined a term called milking to, and that's why the cow. So we coined a term called milking, and what we essentially do is we milk these URLs. We we query them second time, we query them third time, and at different time intervals, and each time a different attack URL shows up. Okay, and why do they do it? They do it because they need to escape Google's safe browsing's block list. Okay, so without actually going through the ad network, we were able to get this. All right, so this is what we termed as milking, and we observed this milking phenomenon for multiple attack campaigns. So for all of these attack campaigns, we identify the milkable domain and we just milk it for a long time. All right, moving on. I think at this point I kind of like completed the system and I can get into the measurement setup. So we had 5 Linux servers in our university and a few desktops at my home, with which we ran this experiment. And basically we crawled 60,000 websites, and probably about 70,000 websites. And we tried multiple 4 different browser OS combinations. For milking, we identified 500 URLs that we could milk. Every URL would be milked in 15-minute intervals, and we did this for 2 weeks. All right. So every attack URL we got from this milking, we immediately looked it up on Google Safe Browsing just to notice how long they need to catch up. Right. And okay, in terms of more results, we found 200,000 landing pages. So basically, as a result of our screenshots, 200,000 pop-ups popped up. And from these 200,000, we identified 130 clusters. So of these 130 clusters, 22 clusters, only 22 clusters were not directly related to any attack campaign. Whereas, so if you subtract that number, you'll see that maybe 108 of them were directly attack campaigns. So this kind of like proves our intuition that clustering is a good technique. Even these 22 clusters, although they were not directly related to attack campaigns, 21 of them were associated with park domains, adult ads, and low tier URL networks, URL shorteners, which are often associated with malicious ads. Okay, moving on. What are these 108 clusters we discovered? These 108 clusters together constitute 28,000 clicks that we made, which were all kind of like malicious. So these can be categorized into 6 different categories, which are kind of like similar to what I showed before, right? But as a result of our research, we kind of discovered 1 or 2 new campaigns. Let me explain one campaign. We uh, we in a follow-up study actually uh, studied this further, but this is an interesting campaign. So what this does is uh, browsers these days have a push notification technology called web push. And what it allows a website to do is as a user, you can basically say allow notifications from this website. And then that website can, like offline, even though you're not on the website, should give you notifications. So that's just like apps, right? So advertisers wanted to make use of this technology. So what they do is they started abusing this technology this way, and this is what our system discovered. It's, they say, if you're, like, I don't know, on an adult website or something, if it says if you're 18 plus, tap on hello. And but what the LO is doing is not for checking if you're 18 plus or not, but rather it's to force you, socially engineer you into accepting notifications. So from this point on, the website can start showing you notifications. And this will be abused by the ad network to show advertisements, malicious advertisements. All right. So this is what we discovered. One new kind of social engineering campaign, which will be abused by the ad network to show more malicious ads. All right. Another campaign we discovered was kind of similar, but it's a registration scam. So the multiple domain names, they all say, hey, create an account. Uh, if you create an account on this website, then we'll show you a movie. So all of this is fake. So this is not actually a real video player, but it's just a ploy to get you to register on that website. Okay, so these were the different categories we discovered, and these are the overall numbers. So the interesting thing overall here is how many of these attacks are being detected by Google Safe Browsing. Well, very few. So even at a campaign, at a domain level, they're like maximum of 20%, sometimes 0%. And this is not surprising, right? Because the very fact that they show up on our web browsers means they are not being detected by Google Safe Browsing. So yeah, so the detection is very low. In terms of categories of websites, so these are all answers to the research questions that we popped up at the beginning. What are the different categories of websites on which these kind of attacks show up? Mostly on like expected categories, the usual suspects like pornography, free websites with privacy, piracy or copyright concerns, video streams. So these are all the usual suspects. But there were certain interesting categories too, like education, health. So different domains in those were also showing these attack ads. Okay, I guess the most important result for me and most concerning result for me was this. It's this slide. So what we tried to see was now that we have a way to mark ads as malicious or not from the clustering phenomenon, we wanted to see how many of the ads that pop up as malicious, how many of them are actually malicious, and how many of them are like how many for each ad network, how many malicious ads are being shown and how many are non-malicious. So we wanted to get a percentage, and we saw that for some ad networks such as, I guess, AdCache and AdStera, more than half of the ads that they're showing were malicious. So this was a real concerning thing, because this basically means that maybe they are almost willful partners in this, right? So which was a very concerning thing. Even we had like something that says 65%. So almost many of the ads that show up via these ad networks are all social engineering attacks. And this, we think, is a very important problem, and something that the community should focus on. All right. Moving on, our system, a feature of our system is it's not restricted to a certain ad networks. So we attribute ads to ad networks based on redirection chain. But if we notice that a certain redirection chain, we cannot identify which ad network it is, then it will show up as unattributed one. So those unattributed ad networks, we can manually conduct inspection and identify newer ad networks that are involved in this. As a proof of concept, we looked at 50 of those logs, and we identified 3 new ad networks, and we were able to add them to the chain. So this kind of like continues the feedback loop, where we can start with a few ad networks, but we can add newer and newer ad networks. All right. Moving on, in terms of milking, um, we noticed that like uh, the milkable URLs by definition again should not be detected by Google Safe Browsing. So as expected, kind of like very low percentage were detected by Google Safe Browsing. But even after a period of 1 week, the detection percentage was still pretty low. It was still less than 20%, meaning that for these particular attacks, Google has to increase their blocking, especially in certain categories where it's like scareware, where it is really low. All right. Um, yeah, that concludes our my presentation. So all we've open sourced the entire project code, and like I said, we have a follow-up work whose code also we've completely open sourced. And I think in conclusion, one thing I want to say is that as a community, like if there's students out there who are looking for new projects, one way you could focus on is uh, see how these ad networks are doing things, because this is one avenue a lot of malicious ads or malicious attacks are popping up. So you can focus on them. And if I go back and look into how this project came into existence, it all started with like something that I saw in real life, well, and trying to inspect how that is happening. So I basically what I'm trying to say is that that's like one way to go about. So a lot of these things, as I keep on focusing on the say social engineering sector, what I notice is that the attackers, their conversations are very much in the world out there, in the open world. So it's as a research community, a security research community, just by following on what these conversations are in those forums that are publicly being made, I think it'll give us many more fruitful ideas. And if you're interested, please reach out to me, and I'll be happy to discuss any of this in more detail with you all. All right, so that concludes. I'll put my slide here to take questions. Um, Unfortunately, no. So, like I showed you in that one particular slide, and I think in the follow-up work that I was talking about, we do actually an experimental comparison with ad blockers, and in both cases, they are not good enough in mitigating these attacks. And there's a reason for that. The reason is that ad blockers are based on trying to block them statically, right? So static blocking is not good enough because they are slow. Any static blocking mechanism is slow. There has been research into machine learning based ad blockers. Like for example, Brave as a web browser has been doing that, and there's some research from University of Iowa published recently that kind of like tries to look at ad blockers from a machine learning perspective. So these are interesting approaches, but they're not being used yet in practice. So to answer that, um, kind of they are partially effective but not fully. And more importantly, the ad networks are fully aware of ad blockers, because these ad blockers are like open technology, right? So they ensure that they are one step ahead of these ad blockers.
All right. Fanny, thank you so much for this great presentation. I believe Douglas had his hand up. If you wanted to go ahead and put your question in the chat so Fanny can answer those questions. If you have those, please do so now.
Sure. I think there are a couple of questions already, so just trying to answer them. Um, all right. So do you need heuristic ad blockers? Well, as long as they're robust, we need robust ad blockers. So again, machine learning ad blockers, I believe, are probably one step in the right direction. But uh, to be honest, I feel it's still in infancy, that research. And I think we need more and more research from that angle. And with any machine learning projects, there'll be false positives, there'll be false negatives, and those are certain things also that we should look into. Um, Again, we might be running out of time, so I'll be happy to take these questions further offline, because this is one interesting area of research for me. I understand how to recognize invalid domains, but those pop-ups like for Adobe don't seem to have. Oh, well, it didn't have the URL because our system doesn't capture the URL bar. So sorry about that. But if for a user it does show up these pop-ups, they will be able to see the URL. Most probably. I mean, again, that's a very good question because certain browsers, back in the past at least, used to enable a feature to hide the URL. I hope they're still not doing it because it's very, very bad practice. But uh, don't go by these screenshots because these were taken by our system and our system doesn't capture the URL bar. So it only captures the content of the web page. So at least as far as I know, I think Chrome always shows the URL bar and they don't disable hiding of URL bar because it's a very bad practice. And if they are doing it, I guess as a community, we need to point it out because they will be immediately abused by these attackers.
Fanny, that there is a question in the chat box. Having gone public, have you seen countermeasures appear from the bad guys, and how quickly does it happen?
Oh, unfortunately, all of this research we presented is only for the researchers. I get we didn't like design any countermeasures that can be used in web browsers, right? So that's actually we are in the process of seeking funding from NSF for that. To be honest, so we haven't used like this is a research concept, and we haven't really implemented this in web browsers. So I don't think the bad guys care. So they'll only care once things come into play in the real world. It'll be interesting how they will adapt to this, but yeah, so far they are not concerned with this. But I at least thought that the web browsers can or the ad blockers can focus more on ad networks. But I guess that's part of the reason why I'm making this presentation to spread this message of focusing on ad networks because they seem to be a bottleneck that we can probably easily block. But unfortunately, as much as I know, there have been no defenses focused on specific ad networks.
Okay, and I think there is a question in the Q&A. When you said you used screen capture, what file format did you use in your research and or data gathering?
Oh, if you're talking about like screenshots, like I said, the crawler was based on Puppeteer. They have a Python port, and specifically, I used that for that. For for capturing the JavaScript logs and the redirection chains, we used JS Graph. So the so it was published in NDSS in 2018, I believe. This is the work that we did. And so it basically contains a modified version of Chromium's open source browser. And we made modifications so that we can capture all JavaScript API calls. So that's what we used for capturing the JavaScript side of things. For the screen capture, for the screenshot, we basically used Puppeteer, Chrome's project, which allows you to programmatically control a browser. So if you want to close tabs, if you want to open tab, if you want to switch tabs, everything you could do with Puppeteer. It's essentially like Selenium, but it's more meant for Chrome browser. So as a result, you can like finally control it better, right? And we were not restricted on. We didn't want to generalize on different browsers. We can fake the user agent to kind of like pretend to be whatever we want. So we were fine with using Puppeteer. And for some reason, Puppeteer it doesn't annoy ad networks, whereas Selenium, they were able to detect Selenium and they kind of like changed their behavior the moment they see that we were using Selenium. So that's why we used Puppeteer.
All right, well, I don't see any other questions. So Fanny, thank you so much again for that great presentation. Thank you to everyone for participating. And we look forward to the upcoming Tech Talks and forums in the new year. So have a great rest of the week and stay warm and safe. Thank you again, Fanny.